All right. Okay. Okay, so again, what we're doing is we're looking at this example of factor by grouping, okay? And again, it's always good to get a GCF, to get the GCF first, and then you want to, factor it out. And basically here, okay, you can see that since we have a non-zero constant term, okay, because of that, we can't factor out x, okay? We cannot, let me see, we cannot factor out x at all. So because of that, we can take m to be 0. And 2 itself, let me get the pen. This is actually, okay, a factor. 2 itself is a factor of 4 and 8. So 2 is a factor of the other coefficients and the constant term. So 2 is the greatest common factor among the coefficients and the constant term. Okay, that's good. I mean, if you were to list the factors, okay, if you were to list the factors of 2, 4, and 8, you would see that the biggest factor in common is 2. Okay. So because of that, our GCF for the original polynomial, right, that is just 2. Okay, that's cool. So let's factor that out. So we're going to factor that out, okay? All right. By factoring it out, this is what we have to do, okay? Right, remember you put it in front. Then what you have to do is you divide like so, right? You have to divide because that's how you figure out what's left over. And now, let me just see. Can everyone still see?
Yeah.
Okay. Just wanted to be sure. Awesome. Okay, so because you factor it out, that's how you get what's left over, right? And that's hopefully what you can see here, right? You have 2 and then you have times a bunch of other stuff. And when you actually do the division, like for instance, in the first quotient here, 2x cubed over 2, the 2's cancel, and that's how we get x cubed at the bottom. 4x squared over 2, that's just 2x squared because 4 over 2 is 2, and so on and so forth. So that's basically how we factor out the first GCF. Okay, that's good. So now we have the GCF factored out. So now what's left over is, oh wait, sorry. No, darn it. There we go. We have to factor out what's in parentheses here. We have to factor this thing out. Okay? So we're going to do that. And again, with factor by grouping, right, what do? Well, what we're going to do is we form 2 groups of 2. Basically, the first 2 terms, that's going to be a group, right? And the second 2 terms is another group. And then we have to factor each of these groups individually. So that's what I'm going to do here. Now, if you have x cubed minus 2x squared, right? Well, notice the smallest exponent of x, that's just going to be 2, right? That's the smallest exponent of x. We have a 2 here. Remember, if the coefficient's 1, we don't write it. But what's the greatest common factor of 1 and 2? Well, it's just going to be 1. I mean, really, the only factor of 1 is just 1 itself. Okay. So our GCF here is going to be x squared. So we're going to factor that out. And that's what I'm doing here. Okay. As you can see. So what we have here is we have x squared in front. Then we divide it as here. And remember, when you divide it, right, you have to divide into each individual term, as you can see. And x cubed over x squared, that's just x, right? 2x squared over x squared, right? That is equal to 2. And so what we get then is x squared times x minus 2. So now what we want to do is factor out 2x minus 4. Okay. I keep checking to see if people can still see, so that's why I keep going back like this. Okay, so we have 2x minus 4, right? So now notice we can't factor out x at all, right? There's a term here with no x's. In other words, we have a non-zero constant term. So the smallest exponent of x, we could take that to be 0. Again, that's not really precise to say, but for this class, it's okay. I mean, for the class, yeah. Excuse me. Notice the greatest common factor of 2 and 4 is 2, right? How do we know that? Because the only factors of 2 are 1 and itself, and the only factors of 4 are 1, 2, and 4. In other words, 2 is a factor of 4, so 2 has to be the greatest, the biggest common factor. So we can factor 2 out. In other words, the GCF of this thing is 2. So we're going to factor that out. And that's what I'm doing here. Okay, and again, when we factor, right, what we do is we divide to see what's left over. And that's what I'm doing in the last line, right? We divide, so you get 2x over 2 just becomes 2, right? And 4 over 2 becomes 2. Now notice here, you can actually see that we're in good shape. And how do I know that? Well, because, okay, in parentheses, we have something in common, right? X minus 2. That's really what you want to happen when you do factor by grouping. You want what's in parentheses, those two groups, you want them to have something in common. And in this case, we have x minus 2. That's good. So here we have this. So the x minus 2, we can factor that out. And that's what I'm doing here. So we factor that out. We put it in front. And I put it in parentheses here, just hopefully it makes it easier to see how you divide and how you get this. Namely, we divide this into the sum, right? Because we have to see what's left over. And this is how you divide. When you divide into a sum, you divide into each term. And that's what I'm doing here. Let me draw a bit. And hopefully you can see that when you divide like this, these are going to cancel. Like so. And so when we do that, we're left with this. And so finally, this whole sum, which is this, is equal to this thing. So now it's factored. And so remember, this was the original, right? Well, the original, first we factored out a 2, then we factored what was in parentheses here to get this. So now we're good. Okay. Okay, yeah. Okay, so what I'm going to do is I'm just going to keep going because, again, so I know we lost a little bit of time, but not much, though, so that's okay. Okay, but does everyone, yeah, you know what, let me do a poll. I like to see what people understand or not. So yes or no, does this make sense? Does this make sense?